So most of these problems will have multiple ways to work them. I will show you one of the ways, and as we're doing example problems in class, I try to show you multiple ways, but I'll show you one way today, and that way you can see at least a way to work each problem. So for problems 1 and 2, we're trying to write an equation in slope-intercept form, and remember, slope-intercept form, that's y equals mx plus b. So we'll need a slope and we'll need an intercept. So looking at this first problem, I can see that my slope, remember y2 minus y1, so we've got a minus 4 minus 2, and then we have an x1 minus x2 is going to be a 2 minus 0. So we've got a minus 6 over 2. So we have a slope of negative 3. And without any work at all, we see that our intercept, x is 0, y equals 2. That's our y-intercept. And so this equation is y equals negative 3x plus 2. All right, we'll slide over here and look at number 2. You'll notice that this graph doesn't have a point that shows the intercept, but we can still see that there is an intercept down here at the bottom. So let's go ahead and look at slope. And so slope would be y2 minus y1. So minus 3 minus 1, and then minus 1 minus 3. So negative 4 over 2. Yep. All right, so that gives us a slope of a negative 2. And again, we don't see a point there, but that line clearly crosses the y-axis there at 1, 2, 3, 4, 5, negative 5. So then y equals negative 2x minus 5. All right, we're going to jump down here to 3 and 4. So graph each equation. Again, several different ways. One of the things that we talked about in class was this point slope form. So this is in point slope form. So I know that right here, my y2, excuse me, not y2, my y1 equals negative 2. And right here, my x1 equals positive 1. And you go back and look at your point slope form, and you'll get that. And then we have a slope of 4. So if I go to x is 1, y is negative 2, that's where that line starts. And a slope of a positive 4, okay, 1, 2, 3, 4 over 1. And then we can do that several times. And then we can also go back the other way. And there's our line. Okay, number 3. That was 3. Number 4. This one is in standard form, which we're not interested about it being standard form or not standard form. When we graph lines, we've typically put them into slope-intercept form. And so we could do that to this problem as well. Or, again, remember back, if it works out well, x equals 0, y equals 0 gives us 2 points that we can work with. So in this equation, if x equals 0, y would have to equal negative 3. And if y equals 0, x would have to equal 2. And so there's our points, right? So 0, negative 3, 2, 0. That's our line right there. It even shows us our slope of up 3 over 2. So we could keep going up 3 over 2 to get the rest of the line. And so using zeros, x and y intercepts was an easy way to have done this problem. Okay. We could have just as easily, I'll go and show you this way, we could have just as easily solved it for y and then graphed it using slope-intercept. So let's subtract 3x from both sides, divide both sides by negative 2. There's your slope, and there's your intercept. Intercept was negative 3. Slope is up 3 over 2. Okay. 5, 6, and 7. Again, we're writing the equation of a line in slope-intercept form. I don't want anybody to feel bad, but slope-intercept form. Y equals mx plus b. Like if I know my slope and if I know my intercept, then it simply plugs into the form. So slope is 3/5. So y equals slope times x. My intercept is -4, and so that's it. Y equals slope was -2 times x. Intercept was 9/2. Okay, and you could have written 9/2 in a lot of different ways, but that's what it is. Y equals slope of 7 times x plus intercept of 1. Okay, slope intercept. Okay, 8, 9, and 10, and really probably 11 as well. 8, 9, we're looking for slope intercept form again. This time given 2 points. So we don't have a slope, so we have to find a slope. So that's our y2 minus y1. So y2 minus y1 equals x2 minus x1. So -8 over 6, which reduces, let's make sure we're reducing, so that's -4/3, and then choose a point. So now we've got a point and a slope. So we're going to go y minus y1 equals slope x minus x1. Okay, and so simplifying here, we've got y equals, so -4/3 x, and then distributing, gives us 8/3. Right, now don't lose track of this plus 3 over here, of this -3 that has to be added to both sides. So if we're adding 3 to both sides, we're going to get a common denominator right there, and that common denominator is going to be 3. So that's going to make this 9/3. So there's my plus 3, and that's what gives us our -4/3 x plus 1/3. Okay. All right. The next one, we actually have a slope, and so we can go straight to our point slope form. We have a point and we have a slope. So y minus y1 equals slope times x minus x1. Okay. Distribution. And then we're going to subtract our 1 from the other side. And so y equals -5/4 x minus 11. Okay. All right. Again, we've got another one where we don't have a slope, so we have to go get our slope. So we got y minus y, and then x minus x. Okay. That reduces -2/5, and so that's the slope we're going to use. So y minus y1 equals slope times x minus x. Little distribution, -2/5 x. This is going to be minus 8/5. Now then we've got to add 5, right, because that 5 has to move to the other side, so we have to add 5 to both sides. Common denominator means that that's not 5, but that is 25/5, right? So there's that 5. And then again, just doing our work with our fractions there, we end it with y equals -2/5 x plus 17/5. Again, a lot of different ways that you gave me 17/5. 3.4, 3 2/5, 17/5 is correct, and then whatever form you give it to me in, as long as it was equal to 17/5. 11 was one of those special cases. Slope of 0. Okay, so if we did our y minus y equals slope times x minus x When that 0 gets distributed, it makes everything go to 0, and then adding 4 to the other side, and just y equals 4 is all that we had left over. Right? Now, you may have given me y equals 0 times x plus 4. Those are equivalent. Y equals 4 is more simplified, so it's probably the better way to do it. Okay, 12 and 13, we were trying to get into point-slope form. And so given a point and a slope, we simply needed to substitute into the form. So y minus y equals slope times x minus x. And that was your final answer. That is point-slope form. Same thing with number 13, point-slope form. So we go y minus y equals slope times x minus x. And that was our answer. Alright, 14, the only standard form problem on the test. X and y on the same side. X has to be positive, no fractions. So let's jump in here by getting rid of, well, let's go ahead and do the distribution. So negative 2/3 x, and then that would have been a positive 4. Okay. Now we can get rid of the fractions here by multiplying everything times 3. So this is 3y minus 12 equals negative 2x plus 12. Again, all that step does is it gets rid of fractions. Now, understanding that x has to be positive and on the same side as the y, and everything else has to be away from that, we would add 2x to both sides. So there's your tx. Leave the 3y where it is. Add 12 to both sides. And that would be your standard form answer. Okay, I zoomed out just a little bit here just so that you can see that this section of problems 15 and 16, these are dealing with slope-intercept form through a point parallel to the graph, and the next two problems will be slope-intercept form perpendicular to the graph. So I've got to pass through a point, and so I need a slope. This particular graph is already gives me my slope, and parallel says same slope. So we're going to go y minus y equals slope times x minus x. Point slope form, right, we get to simply plug into, but we have to algebraically manipulate to get into slope intercept form. Okay, so here we go. Let's do a little distribution. And then the 2, we have to add 2 to both sides. And minus 2 plus 2, that cancels out. So that y equals negative 1/4 x. That was our final answer. Okay. Number 16, you don't see the slope, and so we have to solve that equation for y, slope-intercept form, so that we can see what the slope is. Dividing both sides by 3. So our slope is negative 4/3, and parallel means use the same slope. So here we go. Y minus y equals slope x minus x. Alright, a little distribution. And then add 3 to both sides. And so that would be your final answer there, negative 4/3 x plus 19. Again, I've zoomed out here so that you can see that we're dealing with perpendicular, but we're still going to do slope-intercept. Okay, so the slope of this line is 1. So the opposite reciprocal slope, opposite would be negative, reciprocal is still going to be 1. So the slope that I need to use will be negative 1. So we'll go with y minus y equals slope times x minus x. Okay, so distribute the negative. Subtract 1 from both sides, and that would be your final answer. Alright. Number 18 is not in the right form, so we have to get the y by itself. That's the only way I can see my slope. Divide both sides by 3. Okay, so this slope is -3, so my perpendicular slope is going to be opposite reciprocal. Okay, so we go y minus y equals slope x minus x. Okay, so we've got 1/3 x. What's that going to be? Plus 2, and then we've got to add 6 to both sides. So y equals 1/3 x plus 8. All right.